Hello, in this video we will be reviewing the 2015 number 2 FRQ. This FRQ is primarily based on the topic of vectors. Problems. A lot of the times the formulas are extremely important to memorize. For this particular vector FRQ, the derivative, the speed, and the distance or arc length formulas are needed. So you can pause the video right now to look over these formulas and memorize them. For many vector FRQs, once you know these formulas, it's really easy because a lot of the times you can just plug in the numbers that they give you to solve for the answer. So knowing these formulas will be very, very handy. The problem gives us the velocity vector of cosine t squared, comma, e to the half t. At t equals 1, the particle is at the point 3, 5. For part A, it says find the x-coordinate of the position of the particle at time t equals 2. So, since the problem already gave us x of 1, we can just plug that in and then find the integral from 1 to 2 of cosine t squared, which is the x coordinate. So, we know that x of 1 is equal to 3, so we can just substitute that in. And then, by plugging into your calculator the integral from 1 to 2, you will get that the answer is 2.557. So for this problem, you will get 1 point for setting up the integral up here. You will get a point for making this initial condition with x of 1, and then you will get your final point from the answer. So a helpful hint here is that you need to look at the conditions they gave you in the beginning. So like they gave us t equals 1 at the point, at t equals 1, the point is 3, 5. So you can use that to your advantage to solve the problem. Part B says, for t is less than 1 and greater than 0, there is a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? So what it's asking for is the derivative of the position vector. And what that is just the velocity. So they already gave that to us, so all we do is plug it into the formula for the parametric derivative, which is dy over dt over dx over dt. And we will get e to the half t over cosine t squared. Since it was asking at what time is the slope equal to 2, we can just set this function equal to 2, and then once we solve on a calculator, we'll get that t is equal to 0.840. So this problem is actually very easy. You just need to understand that it's asking for the derivative when it says line tangent to the curve. So the tangent is the derivative. And you also need to know how to use your calculator to solve for the time. So the scoring guidelines for this one is you get 1 point for finding out this function for the slope, and you'll get 1 point for your answer. So part C says find the time at which the speed of the particle is equal to 3. So this problem is another simple one. You need to remember the speed formula, which is the square root of dy dt squared plus dx over dt squared. And we know that dy dt and dx dt are given as the velocity vector. So we can just plug those values in as cosine t squared and e to the 0.5t. And it was asking at what time is the speed equal to 3, so we can set speed equal to 3. So after simplifying, we'll get the square root of cosine squared t squared plus e to the t is equal to 3. Then if you use your solve function on your calculator, you will get that t is equal to 2.196. This problem is very easy because all you need to do is just remember the speed formula and then set up this equation right here. So you'll get 1 point for your speed in terms of t, and you'll get 1 point for your final answer. So just remember, you need to know these formulas. Part D is very similar to part C. It says find the total distance traveled by the particle from time t equals 0 to time t equals 1. This is another very easy problem because all you need to do is find out the formula and then plug and chug in your calculator. So the key formula in this one is the distance formula, which is the integral from 0 to x of the square root of dy dt squared plus dx dt squared. So since they said t equals 1 to t equals 0 to t equals 1, we'll just plug in the integral from 0 to 1, and then again we have our velocity vector, so we'll have cosine squared of t squared plus e to the t dt. So after you plug this into your calculator and solve, it will give you 1.595. So all you have to do is just plug and chug in your calculator and remember the distance formula. So again, to recap for all these problems, the majority of the strategies is just to remember your formulas. So we went through the derivative formula, the speed formula, and now we have the distance formula. For part D, the scoring guidelines is 1 point for your integral setup, which is this one, and 1 point for your final answer. Some similar problems to practice through are the FRQs from College Board from 2000, number 4, 2001, number 1, and 2003, number 2. So these are all vector problems, vector FRQs, and they're very similar to the one we practiced through today. And you will see after going through them that a lot of these problems are just plug and chug after you find out the formula or after you know your formula for each of these vector problems. So I'd say one of the most important things in these problems is to memorize those formulas and understand what they mean when they're asking for it. And for other types of PPV problems, you can practice 1999 number 1, and another good one is 2003 number 3, which is a polar problem. For these problems, you can just find them on the internet by searching Calculus BC FRQ and then the year number. Thank you for watching.